So hello everyone, myself Aditi, and today I'll be solving the very first LeetCode Daily challenge problem on YouTube, and the question is find in mountain array. The question belongs to 12th of October 2023, and the question says that an array is a mountain array if and only if the length of the array is greater than equal to 3, and if there exists some index I such that elements up to that index I are in strictly increasing order, and after which the elements are in strictly decreasing order. So in the question you are given a mountain array. They are asking you to return the minimum index such that the value at that index is equal to target. So if in case that index exists at which the value is equal to target, you will simply return the value of that index, otherwise you will return -1. And there is one more condition, that you cannot access the mountain array directly. You can only access using a mountain array interface. So what is the mountain array interface? It is such that if you have to return the elements of the array at index k, you will use this function. If you have to return the length of the array, you will use this function, right? So in order to understand the question in a better manner, you can take this example. Let's suppose we are given an array which is 1 2 3 4 5 3 1, and the target value is given to us as 3. Now we can clearly see that the values or the elements in this array, they are strictly increasing up to 5 and they are strictly decreasing after 5. What does that mean? It means that 5 is the peak element, right? From 1 to 5, 5 is the greatest, and from 5 to 1, again 5 is the greatest. So 5 is the peak element in this whole array, right? So this gives us some intuition that you can divide the whole array into two parts, one up to 1 to 5, another one from 3 to 1, and here or this way we can apply binary search. Okay, so in this input example, we are given target value equal to 3. Now we have to search for an index at which we get the value 3, and then we will return the index. So let's search. Do we have value 3 in the array? Yes, we have spotted 3 twice, right? So the first 3 occurs at index 2. Since it is a 0 indexed array, this is 0, this is at 0th index, this is first, and this is second. So right, this first 3 just exists at an index 2, then this is index 3, this is index 4, and this is index 5. So basically there exists 2 3, right? Or you can say 3 exists twice in the array, one at index 2, another at index 5. Since you were clearly asked to return the minimum index, right? So you will return 2 and not 5. I hope this is clear. And let's take another example. We are given 0 1 2 4 2 1. Again, it is clearly visible that the elements in the array are strictly increasing up to this point, that is up to 4, and then they are strictly decreasing. Now they have given a target value as 3. So let's search for 3 in the array. We can clearly see there is no value that matches the target, so we'll return -1 in this case, right? So let's get back to the code. As an intuition, we can think of binary search, and let's see how to implement it. So like I said, we can only implement it when we have the peak element, right? So first let's initialize the peak element. What should be the peak element? The peak element should be int peak is equal to find peak in what? Find peak in mountain array. Okay, so find peak is nothing but a function which is used to find peak in a mountain array itself. It is specifically designed for mountain array and not any usual kind of array. So now we'll initialize result. Okay, let's initialize result as. So before initializing it, let me tell you, we are going to divide the whole array into two parts, and by that I simply mean that firstly I'll divide the array starting from index 0 up to the peak element, and then I'll just use the other part of my array starting from the index peak plus 1 up to the last element. So obviously, like we said, we have to return the minimum index. We are going to search the target value first in the left side of the array or up to peak. Okay, so let's search binary search ascending, that is in the increasing part, that is up to the peak element. Okay, so what are we going to pass as our inputs? We can just pass our mountain array. Okay, we'll pass integer target. We will pass since we are searching from index 0 up to peak, so we are going to pass arguments as mountain array, integer target, 0th index and the index peak. Okay, so we have initialized the result. Now, as given in the question, if we find such index, we will return the index, otherwise we will return -1. Okay, so first we are done. When we are done with searching in the left part of the array, if we find that result is not equal to -1, what does this mean? This simply means that we have actually found a value or an index at which the value is equal to target. So if we have already found, what are we going to do? We are going to return the result. Fine. But otherwise, what are we going to do? Otherwise, we will just return, we'll move to the right part and we will start searching for our target value in the right part. Okay, I hope this much is clear. I hope the code part is clear. And return binary search descending, we'll again pass the arguments as mountain array. Okay, we'll pass the array, we'll pass integer target, we will pass the element starting from the, or you can say from where it is descending. Obviously it is descending from index peak plus 1 till mountain array dot length -1, right? So we'll return this now. So basically this is the end result, right? Now in order to find the peak element, let's find peak. Okay, let's find peak. So we are going to find peak here. We are going to pass array as our argument, mountain array. Okay, this is, we are taking this method, and now let's initialize our left as 0. Let's initialize our right as mountain array dot length. We have to use the interface, right? We have to you have to use the interface correctly, and in order to use its length, you have to use this. Okay, so we have initialized left and right. Now what are we going to do? We are going to check while left is less than right. We are going to initialize our middle element, which has to be equal to left plus right minus left divided by 2. Okay, so we have initialized our middle element, and now we'll check if the value at index mid, okay, if we see the value at index mid is if we see if it is less than the value at index mid plus 1, what does this imply? This simply implies that the middle element is not the peak element. We are still continuing in the ascending part. So this simply means that mid plus 1 is also greater than mid, right? So basically mid is not the peak. Okay, and up till this condition is met, what are we going to do? We are simply going to assign left as the mid plus 1 value. Okay, otherwise what are we going to do? Else we will just assign right to mid. Okay, I hope this is clear, and I hope this is clear. Now after this we will return left. Okay, now we are going to search our target value in the left part of the array, or you can say we are going to search it up to the peak element. So binary search ascending. What are the parameters we are going to pass? Mountain array. We are going to pass our integer target. We are going to pass integer left, integer right. Okay, also what are we going to check here? Now again we'll check while left is less than equal to right. What are we going to check? We are going to check, yeah, so we are going to check if integer, sorry, if mid, yeah, we clearly know mid is equal to right minus left divided by 2. And what are we going to check here? We are also initializing that mid value as mountain array dot get the value at index mid. Okay, so we have initialized it. Now what are we going to check in the left part of the array? What we are going to check? We'll just check if the mid value is equal to target, we'll simply return mid. Okay, we will simply return mid. But if this is not the case, there can be two cases, right? When the middle value is greater than target, or the other case will be when the middle value is less than target. Since we are searching in the left part, else if right now, yeah, so what are we going to search again? Yeah, just give me a second, guys. Yeah, I hope there is no error. And sending, yeah, there is no such error. And yeah, so we are first, we'll just search mid value. If mid value is less than target, what are we going to do? If it is less than target, we'll assign left as mid plus 1. Okay, otherwise we will just assign right as mid minus 1. Okay, and the same procedure we are going to follow for the descending part also. Otherwise we are going to return minus 1. And yeah, so let's copy paste the same for the descending part. And yeah, that's because the code remains same. The only difference here is you have to check if the middle value is greater than, if it is greater than this, then left will be mid plus 1, else right will be mid minus 1, and then we are going to return this. Okay, and yeah, let's hope it works. Let's just hope it works. Okay, there is some error in line 13. I hope to find the error. Yeah, so I hope this need not to be mentioned. Same. Okay, I hope this works. Okay guys, so this is the basic mistake I did, and hope there is no other error in the code. Let's see. My god. So guys, yeah, I have just found the error. So basically what I did is I just copy pasted this and I didn't change this to descending. So basically there is duplicate occurring for the same function. I hope this works. Let's see. Yeah, so it works now and you can clearly see it is accepted. Okay, let's try to submit the code. Yeah, okay, I hope the solution works for you, and if there are some doubts, please post in the comment section. Also, I want to mention one more thing, like I'll be um, eager to post daily challenge videos on YouTube if you feel like. Also, let me know about the language barrier. If you want completely English videos, that's fine. If you want English or Hindi English mix videos, that's also fine. I just want you guys to let me know. Thank you so much for watching.